Okay, good morning everybody. Today we're going to do Unit 8.3, but before I do, I want to show you the two worksheets that we started last day, just so that you can get a kind of check your work. So this is 8.1, and I'm just going to leave it there. I want you can pause this video and check off your answers. So I just want to highlight maybe a few. For example, this one here, 1 lead and 2 nitrate. So you put the 1 lead, because a nitrate is a polyatomic ion. I have to put the brackets around, 3, and then put the 2 for the 2 nitrate. This one similarly, 3 chromium, and 2 phosphate. So the phosphate ions are here, and I've got 2 of them, so I have to put the phosphates in brackets, 2 of those. Sodium carbonate is only 1, so notice there's no brackets, there's only 1. Similarly, ammonium hydroxide, 1 ammonium, 1 hydroxide, no brackets. And you can see the same thing with barium nitrate and lead phosphate. Okay, so that's the first one. The second one I've only partially done because I still want you to struggle through a little bit of it, and that is 8.2. And so in this one here, this is a little up in the ante. They're not going to tell you directly how many ions of each you should include. You have to determine that by looking at the combining capacities, or the ions. So I think we did the first 2 together. Lithium hydroxide. Lithium from your table has a combined capacity of 1. Hydroxide is a -1 combined capacity, so it's a 1-to-1 ratio. So you end up with lithium hydroxide. Calcium fluoride. Calcium has a +2, fluoride a -1. So do the switch. CaF2. Silver and sulfide ion. Silver's 1, sulfide is -2, so do the switch. Ammonium has 1, sulfide has 2, do the switch. Notice the brackets. Magnesium oxalate, magnesium +2, oxalate -2. When you do the switch, you have to reduce this one, because normally it'd be Mg2 C2O4. No, they balance, so that's an issue. Same with this one, Ba +2, SO4 -2. It's a 1-to-1 ratio. If I switch to Ba2 SO42, the 2's can be what's the word? I've lost the word. You guys probably know what I'm trying to find out anyway. I was trying to say anyway. So I'm just going to, bit by bit, again, you can pause this video. The acetate ion that you have in your on your tables is different than mine. Mine, if you count up the number of carbons, hydrogen, and oxygens, you come up with the same number. This is actually a better way of writing it, because this actually tells you what it looks like. Like if you were to actually see a molecule of silver acetate. Sodium chromate, Na2CrO4, lithium sulfide, LiS2. So I'm going to show you the rest. And you can pause whenever you need to. And that's the bottom. I've not done these. I want you to go back and complete these on your own as much as you can. The only difference is, for example, I'm looking at copper chloride. Copper, this too tells you the combining capacity. So Cu plus 2, chloride from your table is minus 1. So you're going to switch these. So this would be CuCl2. Iron 3 oxide. This 3 tells you the combined capacity of iron. Oxide is always in -2. So do the switch. So you get the idea. Okay, so I want you to go back and do those if you have not already done so, and we'll maybe look at that the next day. Okay, so here we are in 8.3. I'll get this centered, don't worry about it. I can see it's way out. Try to this document you should have received by now. No problem. Should be no problems. If you have problems, get a hold of me and I'll see what I can do for you. So it is time. It is time to learn how to properly name compounds. Compound naming is determined by a group called UPAC, which stands for the International Union of Physical and Applied Chemists. So all over the world they're going to give you, the names are going to be the same. So table salt, for example, is called, you guys probably know this one, sodium chloride. So table salt will be the common name. Sodium chloride is the chemical name. Baking soda, some of you may know this as well. This is called sodium bicarbonate. Or sodium hydrogen carbonate. That is becoming more and more popular, to say it that way. Chalk is calcium carbonate. And vinegar is actually a dilute solution of something called acetic acid, or sometimes even known as ethanoic acid. Aspirin. Aspirin is actually marketed. If you get it generically, you buy it and it'll say ASA, and ASA stands for acetyl salicylic acid. Now, normally you don't see the dots between acetyl salicylic, boy that's a hard one to say, is usually run together in one word. Okay, so you won't commonly see it that way. So we're going to look at the rules now of naming. So rule number 1 is naming things that are monovalent. Let me see if I can find a highlighter somewhere. Okay, here, I got my highlighters here. I'll grab my highlighters. Come here. Come here, highlighter. So, rule number 1. First of all, monovalent means that these metals only have one ionic charge. Most of these are in group 1 and group 2. So those are the first two columns in your periodic table. Those are all are monovalent. And then there's a few others as well, but those ones for sure. The name of the metal ion is written first. The name of the metal ion is written first in a formula. You already know that. That's review from last day, really. The name is written in lowercase and it is spelled exactly the same way as usual. Okay, so we're going from the last day we went from names to formulas. Now we're going from formulas to names. So you want to think of this. You're starting with a formula. Now you're going to a name. Okay. For example, sodium is, you can see that this is lowercase, and beryllium also lowercase. Okay. Rule number 2. Rule number 2, naming the nonmetal ion the nonmetal ion is written second. Non-metal ion is written second in the formula. Again, just review. To distinguish between nonmetals and polyatomic ions, we give the suffix "ide." So, to distinguish, between nonmetals, ions, and polyatomic ions, we give the suffix. Suffix means it's at the end of the word. So this is IDE. So that means when we're talking about metal and nonmetal, for example, if we look at sodium chloride, this is sodium, chlor, IDE. Okay? So this is what we're talking about here. So that means that if you have two things, a metal and a nonmetal, the name is always going to end in IDE. Oxygen is a special case, so it becomes oxide, and chlorine becomes chloride, and phosphorus becomes phosphide. So basically, you change the ending, the "ine" or the "us" or the "egen" on these three. So where's my? So this is dropped. This is dropped, and you end up with "ide." Chlorine is dropped. The "ine" comes off, and this becomes "ide." And the phosphorus is dropped, and this becomes phosphide. Okay? You'll get used to it. This is one of those things where excuse me, the more you use, as you use it, you become more and more familiar with it, and it actually, you start doing it automatically. You're not even thinking about it anymore. Okay? When we're naming polyatomic ions, this is different. The oh, I'm sorry, you can't see that. So I'm going to go all the way up to the top. So this is rule number 3. So I'm going to, where's my blue? So this is rule 3. Naming polyatomic ions. Polyatomic ions that are positive are written first, like metals. Now it turns out that there is only one. The only one is ammonium. That's the only polyatomic ion. Sometimes I just call them polyions for short. So polyatomic ions are negative are written second, like nonmetals. And there's going to be a few differences. For example, SO4 2-, if you look that up in your table, this is sulfate. So polyions generally end in -ite or -ate. There are a few exceptions. For example, hydroxide is OH-. I think that for you guys, that's the only one that I see on your table. So I'm going to guess that this is the only one that you're going to deal with this year. There are other ones. There's cyanide, and there's a few other ones. Anyway, that be that. So rule number 4. Let's get out my blue. Rule number 4. If the metal is multivalent, such as iron or copper, the ion charge of the metal has to be in the name. So let me write that down. If the metal is multivalent, such as iron or copper, the ion charge of the metal has to be in the name, and the ion charge is written as Roman numerals. So a couple of examples here. So copper 2 is read as and it has an ion charge of +2. Copper 1, say it that way, copper 1, okay? there are a few rule 4b, so that's this part of the above. So in this case, naming multivalents can be tricky. So naming multivalent metals can be tricky. So what you need to do, you need to break it back into its ionic charges. And then step 2, identify which valence the metal is. Okay? So for example, let's do a couple of examples below here. So for example, if I gave you this Fe3 P2, okay, what we have to figure out is what the charge on this guy is. So this charge here is going to be plus, but we don't know plus what. However, we do know that phosphorus is always -3. So -3, I'm going to do a little line down here. This is just to help me figure it out. If this is -3, and I've got 2 of them, 2 times -3 gives me a total charge of -6. Now, because this is neutral, no charge, that means that 3 times some number has to equal +6, so that when I add this to this, the total charge is 0. Okay? So what number, when multiplied by 3, gives you +6? +2, of course. So this is going to be +2. So this means that the charge here is +2. So how do I write that now? Well, this is going to be iron. The number of the charge has to go in brackets. So this is +2, but you have to write in Roman numerals. Don't write it in normal everyday numbers. So it's going to be iron 2. If you look at your table, the P is phosphorus. For us, but because there are only 2, I have to take this, drop that, and this becomes IDE. So the actual name of this is iron 2 phosphide. Okay? Now, what I want you to do is I want you to use this as a template and to do this one. Okay? So pause the video right now, give it a try, and then when you've gone as far as you can, restart the video and check it out. Okay, we're back again. So what we're going to do is we say, okay, we know only one thing. We know that phosphorus is -3. So we've got 1 times minus 3 is minus 3. And I have to come up with 1 times some number that when added to minus 3 gives me 0, or in other words, what number times 1 gives me plus 3. So we know that this is, in fact, the charge is plus 3. So in the end, this is going to be called iron 3, phos 5. Notice in both cases that this number that is here is not the number of iron atoms I have. It is the number of the ion charge. That's really important, okay? Okay. Practice. Okay, I want you to practice now, right now, using this the strategies that I just gave you, and then when you're finished that, there is naming ionic compounds 8.3 and 8. Oops, sorry, you can't see the titles on there. Sorry about that. There's naming ionic compounds 8.3, and there's naming ionic compounds with multivalent metal ions 8.3. And then what I'm going to do is I'm going to make another video so that you're probably going to be spending a fair amount of time on this, and then on the next day I meet you, we're going to score this together. Okay? Okay. Well, my beloved, love you, and like I say sometimes in class, love you, go away, and I look forward to seeing you again soon. Bye now.